Okay, we're going to work on a two-column proof. You can see in this example, we have two columns. This is the structure of a two-column proof. The column on the left will be statements that we're making. The column on the right will be the reasons that justify why we're able to make these statements on the left. It's kind of like, how do you get from point A to point B? You have to follow certain steps to get there, and we're just writing out the details of those steps. So we are asked to prove the vertical angle theorem. We are given some information. So in a proof, you will always be given some information. What you're given goes into your proof. So statement 1, angle 1 and angle 2 are vertical angles. So you can see that's just copied straight down from that given information above. The reason, how do we know that angle 1 and angle 2 are vertical angles? Well, that was given to us. So we're just going to write given. Okay, now if we look at the picture, here's angle 1 and angle 2. Vertical angles by definition are, we have intersecting lines, they're angles opposite of each other. They share a vertex, so those are vertical angles. Next, if we look at our picture, we can see you are allowed to assume that you have a straight line right here. And angle 1 and angle 3 are side by side. So angle 1 plus angle 3 will add up to 180 degrees. Those are supplementary angles. Angle 2 and angle 3, see how we have another straight line, and angle 2 plus angle 3, that will also equal 180 degrees. So both those sets of angles are going to add up to equal 180 degrees. That's because they are supplementary angles. And we're using our knowledge of supplementary angles to be able to say that. So our reason, they are supplementary angles. Okay. Now if we notice what we just said, the measure of angle 1 and the measure of angle 3 equals 180 degrees. Well, the measure of angle 2 plus the measure of angle 3 is also equal to 180 degrees. Because these two sums are both equal to 180, that means they must be equal to each other. We can say measure of angle 1 plus the measure of angle 3 equals measure of angle 2 plus the measure of angle 3. That is the transitive property. We learned that definition in our last video, so that's an example of it at work. That's our transitive property that lets us deduce that, well, if both sums equal 180, then those sums must be equal to each other. All right, so how are we getting from line 3 to line 4? Measure of angle 1 plus the measure of angle 3 equals the measure of angle 2 plus the measure of angle 3. Therefore, the measure of angle 1 must equal the measure of angle 2. So let me just show you. You guys will kind of recognize this side work. If I just take that equation and if I think about it like an equation, measure of angle 1 plus the measure of angle 3 equals measure of angle 2 plus the measure of angle 3. What if I just subtracted the measure of angle 3 from both sides? Measure of angle 3 minus the measure of angle 3 would cancel. Over here, the measure of angle 3 minus the measure of angle 3 would cancel. And we'd be left with the measure of angle 1 equal to the measure of angle 2. And that's why we're able to say that right there. So our reason for being able to make that statement is the subtraction property. We subtracted both sides by the same amount, and our result was that measure of angle 1 equals measure of angle 2. So the subtraction property is what got us there. All right, well, here we're saying that the measure of angle 1 is equal to the measure of angle 2. So if you have two angles that have the same measurement, that means that those angles will be congruent. Angle 1 is congruent to angle 2. And our reason for that is that's just the definition of congruent angles. That's what it means when you have congruent angles. And there's your first proof. Not bad, right? What we just proved was angle 1 is congruent to angle 2, and I just want to make sure I point it out. That's what you were asked to prove. The angle 1 is congruent to angle 2. So we were given angle 1 and angle 2 are vertical angles. We just proved that that means they are congruent. That's your vertical angles theorem. Vertical angles are congruent, and we just proved it.